defined pretty narrowly in this benchmark. In order to solve a problem, the AI model needs to produce a patch that can pass unit tests. So there's a question about whether unit tests can fully capture the quality of the code and whether it's good enough to just pass unit tests. And then a related question is that the setup does not really resemble the real-world issue resolution process. If you look at any bug report threads on GitHub, you might see a long thread of messages going back and forth between the original issue reporter and then the software developer. Usually the problem is clarified over multiple turns, and then the developer and then the issue reporter will also have some discussion about what counts as an acceptable solution before they actually start working on the actual fix. In the Sui bench setup, it's a one-shot process. You provide the AI model with a almost like complete description of the problem, and then the AI model tries to just spit out the patch, and the success is determined by whether or not that patch can pass in automated tests. So human AI collaboration is completely missing from the scope of that benchmark. So we wanted to take a step back, right, and think about what kind of goalposts should we set for the future development of AI in software engineering, since Sui bench style benchmarks seems to be very narrowly focused on just one aspect of coding, right? It's about functional correctness. But in real-world software engineering, based on our own experience and observations, it's much more than producing a piece of code that can pass automated tests. So the overarching motivating question for our research has been, what are the core behaviors AI agents ought to be evaluated for as collaborative partners of software developers? If the industry wants to pitch AI as a collaborator for software engineers, we need to measure them as a collaborator accordingly. And here I'm also invoking one of my favorite quotes from Herbert Simon on the role of designers in this industry. So in order to answer that question, we conducted two complementary studies. And the first study is a content analysis of agent rules sourced from a bunch of different code bases within Google. And agent rules can be thought of as configuration files for your agents, and we have many of those within Google's code base. The main research question we want to answer through that analysis is to identify the kinds of behaviors developers consider to be desirable for the current generation of AI agents. And then we complemented with that content analysis with a set of interviews with seasoned developers who have been in the industry for a long time. We want to learn from them, what counts as key values of software engineering, and use those as a way to check, how durable the findings from the content analysis can be. And we would like the future generations of AI agents to be able to reflect those values developers follow in their own work. So let me maybe pause here for a few seconds. I'm about to dive into the first study. Are there any clarifying questions so far? Okay.
Just a framing question.
Yes.
Sorry. I'm Edwin, current Bay County Vice Chair. Been a designer for a long time. And cognitive science is my background.
Mm-hmm.
So my advisor was a cognitive anthropologist. And so I have a particular view on what's the right unit of analysis.
Mm-hmm.
So the idea here underneath this idea of an AI agent
mm-hmm.
is that it's replicating another developer, right? So
it is.
So the measures are how well does it replicate an actual human developer?
It was the framing by some developers, agent developers in the industry. They would like to frame the final goal of AI agent development or software engineering as a virtual teammate you can rely on to get complex work done. And I think We probably are not there yet, but if we want to embrace that vision, we should at least be honest and evaluate AI as such, instead of just focus on a very narrowly defined task.
Right, so my question, and this may be too large for the research, is to what degree the collaborative capabilities and the sort of like capabilities of the collective pair, let's say, of a developer and an AI agent, or a developer and another developer, how well those will be studied as part of this.
So, so this study is trying to speak to the requirements for human AI collaboration, in the software engineering domain.
This is an example, and yours is an example. So he'll go through some of the examples of requirements. That's an example of a requirement that you made 2 or 3, actually.
Yeah, so this is the exact question we found missing in existing AI coding benchmarks, because usually it only tests AI's ability to generate code from a well-specified problem. But in the real world, usually the input is not that well specified and it requires communication to get to a more complete state of the work.
So let's make sure you can get through your talk.
Okay.
Do you want to take another, do you want to wait for the end of it, or there's another question somebody is interested in?
Also, ask my question later.
Okay, maybe let's
Put it at the end for later.
Yeah,
because you've got a lot you're going through. I can
also
feel it's like a big
things.
River of information. We're trying to hold on to it.
Okay, so yeah, let's go through the next few slides. So I'm going to dive into the first study we conducted to understand, what kind of behaviors we should even benchmark for. A bit more detail about those agent rules. So these are usually just markdown files stored in the code base. These are natural language expressions of the behavior the AI agent should follow. As you can see from some examples here, they can be like workflow instructions. They can be style of the code that the agent should produce. They can be about guidance on handling like errors. You can almost conceive them as kind of a reusable prompt that you want the agent to always consider when it works on a particular part of the code base. And we take those agent rule files as concrete expressions of behavioral guidance for the agent and try to derive a taxonomy based on semantic analysis. So I'm going to show the final taxonomy first and then break down the different pieces in that. So through a semantic analysis of this corpus of agent rules developers put in place to steer the agent towards better behavior from their perspective, we identified 15 different behaviors developers within Google want their agents to demonstrate. And we organize those behaviors under 4 high-level themes. The first 2 themes adhere to standards and process, ensure code quality and reliability, reflect the nature of software engineering at Google. It is very collaborative. It also involves a mature production-grade code base being worked on by many people over a long time horizon. Can you tip it over to Mike?
No, just tip the screen just a little bit so you get your face there.
Oh, okay. Okay, please stay closer to the table. Great. So then the next 2 themes, right? Solve problems effectively and collaborate with developers. They sort of speak to the common shortcomings developers have been experiencing when they work with their AI agents. For example, AI agent can be overconfident in the quality of their work. They might return some code without proactively verify it's actually going to work. Another example is that AI agents can often be very overeager to write code, right? You can send a prompt with a ill-defined problem, and the AI will still give you some code instead of like pushing back and ask you clarifying questions. So that's where some of the behavioral guidance, such as seeking help and clarification, come from. So that's the overview, and let me break it down a little bit and show some example rules from our corpus. Where the first theme here is about following standards and processes, and further relates to two aspects of this idea. The first one is about referencing established coding practices within the company. So for example, there is a rule about following the internal Angular coding style guide, which is quite different from what's available in the public. It has a lot of constraints about how code should be structured. And then there's also a lot of rules about project-specific workflows. So this particular example here is showing how test files should be named and organized in a code repository. So this is a way to almost onboard an AI agent into a developer's own project team to make sure that they would work well according to the established norms. And then the next theme is about a strong focus on code quality and reliability. And it further breaks down into three behaviors. The first one is about code style. And this one is about two things. If we look at this in more detail, it's about understanding the high-level company-wide guidelines on code style, but also relating to the local style in the code the AI agent is trying to modify. And sometimes developers will ask the AI agent to respect the local style over the global styles they might find in documentation for potentially a variety of reasons. For example, the documentation can be out of date, so code sometimes is the source of truth for established style. And then the second behavior in this under this theme is about the long-term maintenance of code. And some of the rules are very much like how you would instruct your new team member, like this one, write for others. Code should be written with assumption that someone else will read, understand, and maintain it. There are also other rules that are much more specific about what to do and what not to do. But you are kind of seeing some sort of shift of mental model. We feel like some developers are start to see AI agents as almost a virtual teammate that requires onboarding and requires coaching to work well with the rest of the team with rules written in such forms. And then the third one is about the robustness and performance of software. And this particular example here is about some avoiding some anti-patterns related to memory leaks and unsafe operations. Moving on from here, the third theme is a relatively large one among the four, and this one is mainly trying to get AI agents better problem solvers, and it includes a lot of wisdoms you would expect a senior developer to share with junior ones. The first behavior is about understanding project context before acting, and the specific rule is about how to handle SQL query. This again is related to this common pattern of over-eager action, right? The AI models are often trained to give the user immediate answer instead of working with the user over a few steps to get to the bottom of the question. But they want AI to kind of take a deep breath and ingest more context before they actually produce code. The second and the third one are sort of in the similar spirit. They want the AI agent to break down a large problem in the user's prompt into smaller pieces and then walk through each step with verification that is initiated by the AI itself instead of requiring reminders from the user. And then the last three behavioral guidelines in this theme addresses a few other common issues while working with AI agents. For example, the AI agent sometimes will do some unrelated work as they explore the code base. So there is some kind of negative constraints introduced by the developers to prevent AI from going through a side quest. And then we have a behavior expectation, such as inferring intent from context, and another related one about learn by example. These are all sort of encouragement to the AI agent and trying to get them reason through the local information present in the code base to make better decisions. So for example, the last example on the slide, inspect other tools in the tools directory and copy their approach. So this is trying to get the AI to be more proactive and autonomous in their problem solving process. Okay, so we are now at the last theme of this taxonomy. This is about collaboration. To Edwin's question, there are quite a few agent rules specifically trying to change the default behavior of the developers agents to make those agents more pleasant to work with. The first category of behavior here is about communicating more effectively, and they are mostly concerned with communication styles. So, for example, in this rule, the agent was asked to never start their messages with "great" or "certainly." You probably have seen those words many times when you work with AI, and the software developers want AI agents to communicate in a very technical and concise tone. The next behavioral category here, seek help and clarification. This again is trying to steer agents away from the default behavior of many large language models. And the developer here is trying to encourage the agent to ask the user questions and also give them additional guidance on how to phrase their questions to be more actionable. And then the third one here, plan collaboratively and analyze trade-offs, is trying to get AI agents to exercise some critical thinking when they respond to the user's initial request and actively identify what information is missing from the user's prompt and work with the user to better define the problem before jumping to a solution. The last one here is quite interesting and aspirational. We have a few agent rules trying to ask the agent to kind of keep a log of its own mistakes and then avoid making the same mistakes again in future sessions. So we collect this data in the second half of last year. So at the time, there was no...
Yes. Just say what percent of files. I think there are percent of files that are impacted by this. Is that what that is?
This was the percent of files with rules in that category of behavior. Yeah. Yes, thanks for that question.
Kevin Boyd asked for that.
Great, thank you. So let's take a look at the last row of this table here, and I'm going to read this rule because it's quite unique. So at the end of every task, upon making an error, you, in this case, the agent, must update the lessons learned.md file. This process is essential for self-correction and knowledge retention. So this is a kind of rudimentary memory system developers have created because at the time there wasn't a system level support for cross-session memory for the agent. And it's unclear how well this works, but this shows the need for the agent to be able to improve themselves over time. So I go through the main pieces of the taxonomy, and before I jump to the second study, which is complementary, I want to pause here and see if there are any burning questions.
There was one over here. Are you ready to ask your question again?
Sure. It's not exactly related to the session that you went over.
Okay.
It was I was riffing off of these questions. Essentially, okay, so the question I had in mind was that there are other stakeholders involved in this process besides the software engineer who would be in charge of, fixing a bug or something, right? For example, those who would then later review the code.
Yes.
Right? And how would you, or have you considered their values or what they want? What if we're doing all of this, but then we're shifting the burden onto them, onto the code reviewers, just yeah, wondering if you have also considered things from their perspective.
Yeah, so the second study might speak to that because we are also trying to understand the point of view from senior developers who are often in the position of like reviewing other people's code. And I think even in the during the first study, the rules are maintained by a team. So these are not individual like personal preferences. These are collectively maintained by a software project team. So they do reflect both the reviewers' perspectives as well as code authors' perspectives. And that's a good question to consider different aspects of the workflow.
And we can get into it a little deeper as we go. And I'm sure your name is, as you ask a question, if you can remember to.
How much time do we still have?
You can go as long as you want.
Well, I'm usually.
Okay, I think you have a half hour. So.
Okay, all right.
Yu Yang from Notion. I think it's interesting that the framework, even though it's for software engineer, because our product is mostly, I think, EPD across all the different kind of knowledge workers, including like engineers plus product, marketing designers, researchers. I feel a lot of this taxonomy actually applicable to other type of job as well, like providing context and like confirmation where it's like follow up. So I think it's more generalizable even beyond this developer community. Also curious, like if you think like any of these are uniquely like more important for software engineer, or generally like this are all important for knowledge workers.
Yeah, I think at a high level that they are probably translatable to other domains. But if you look at the kind of the details and think about how to operationalize measurements, then there will be more differences. For example, in software engineering, there are often like more documented practices, right, to follow. And I think in some other domains, maybe the convention is like less rigorously documented. And code quality might be a unique aspect, right? I think it requires a bit more transformation when we carry that concept of quality to other domains.
I think we can get into that more later too.
Yeah.
Okay.
All right. Well, I'll talk about the second study we conducted, right? Just a reminder, the initial study was based off of like what developers have been asking their agents to do in those agent rule files. So one concern we had at the time was that maybe the taxonomy we derived from those existing rules would only speak to the kind of current state of AI, and we want to make sure this taxonomy is durable and can be used to guide AI development in software engineering for a few years at least. So we wanted to take a step back and consider this general question, like what good is in software engineering, right? So one way to look at this is to ask software developers to help us understand the core values that have been guiding their practice. And we then subsequently used these core values to validate the high-level behaviors in our taxonomy. So these are a set of semi-structured interviews with senior developers from Google, and each session includes 3 main parts. We conducted a kind of value mapping exercise with the participant, asking them to talk through examples where they considered to embody key values in software engineering from their own experience. And then we had our participants discuss how junior developers would grow professionally to demonstrate those values. And then we had them comment on the analogy. Many companies in the industry have been pitching AI agents and the junior developers in the context of the values they have articulated in the first half of this interview session. So a little bit more information about the background of our participants. They work on different teams at Google. Some are backend developers, some are front end, and they are all quite experienced. and use AI agent frequently. Most of them use AI agent daily. One thing that we also emphasize is that they need to have some mentoring experience so they can start commenting on the differences in behavior between AI agents and junior developers they had worked with, since that has been a framing used by many AI builders in the industry. So let's get to the overall finding first. So we found the values expressed by our participants pretty similar to the high-level themes we identified from analyzing the agent rules, and that is reassuring. And we believe the key concepts in the taxonomy can last a while to serve as a useful goalpost for AI development in software engineering. We also found one exception, which is in the area of continual learning and social learning. There is a pretty strong expectation towards junior developers that they should own their own growth, and that growth often comes from taking feedback through review sessions, observing how the team works, and also taking their own initiative to exercise critical thinking, investigate the code base, and learn from senior developers from the team. This is not an expectation towards AI yet, although we have seen some early experimentation around memory system trying to mimic how a junior developer would grow professionally. So let's take a look at the details and also some quotes. As you probably would expect, code quality is a big focus of the discussion in our interview study. The senior developers we interviewed often frame code as a communication medium between humans who needs to work on the code in different times. So this quote from P7 is quite representative. He said, "I would say if we don't pay attention to the quality over time, it's going to bite you back because people come and go. Some people may have this knowledge and they are gone, and we just totally lose that piece." So they see code primarily as a medium that enable people working together, and then secondarily, it's a medium for a computer to understand. And this quality first, this quality first mindset is something our participants thought was not always present with junior developers, and they often gain that mindset through participating in the code review process and getting feedback from their tech leads and senior peers. And they correspond to specific behaviors in our taxonomy. Then the second value, again, not surprising, standards is important in a professional software development environment. P6 said it's not just about functionality, but also overall readability and whether it aligns with the rest of how Google writes this piece of code. So in this case, P6 was speaking generally about software engineering at Google. He was not commenting on AI, but we found very similar sentiments about what good entails in the code going into a production code base. Then the third value is about solving problems with systematical methods, right? And I think the emphasis here was put on understanding the problem sufficiently to analyze the trade-offs of different technical choices. P4 made this pretty clear, right? He said that your level of understanding of the code base determines the code you can write. If you know more, like you have more context over a larger code base, then you know how to design some part of it. Again, he was not commenting on AI, he was just commenting on how to be effective in software engineering in general, yet it relates quite well to one of the behaviors developers want their agents to demonstrate, which is to take time to go through the code base and then analyze the trade-offs more thoroughly. One thing the senior developers we interviewed pointed out was that junior developers often make a similar mistake as AI agents, which is to jump to a task too quickly without sufficiently understanding the implications of their chosen approach. And this is something that both AI agents and junior developers kind of needs to avoid. And then the next value is about collaboration and teamwork. So this speaks to two specific problems. One is that junior developers often don't socialize their work enough. And this quote from P6 is directly about that pattern, right? The expectation was that they, in this case, junior developers, should proactively communicate, avoid working in the hole for 3 days. And I think AI agent differs in this case because the communication is driven by the user in current AI systems. So the rules around the communication quality are usually around tone and style, but this is something we could expect when AI agents become more like proactive. You might expect that the AI agent also needs to provide a level of transparency about their state with the user, so the user can steer their behavior in a timely manner. Let's look at the last major value we learned from this set of interviews with senior developers at Google. So this one is where the difference shows up between junior developers and AI agents. There is a lot of expectation about how junior developers grow their career and skill set, and here are two really interesting quotes from the participants we interviewed. So, for example, P10 was commenting on how someone would start understanding team norm. Right, there's some sort of team norm that needs to be learned over time, or through talking to the senior people on the team. This is something AI can't do today because it lives in a box, and all the actions are usually driven by the user. And we've seen, again, some examples of the user trying to get them to learn from past sessions, sort of mimicking how a junior developer would gain experience being on the team for a while. But this is still pretty experimental, and might point to a future direction of enhancing today's AI's capabilities. And when they compare AI agents with junior developers, they often characterize their experience with AI agents as guided correction. They don't believe AI agents can improve themselves. If there is any improvement over their default behavior, it is through careful context and prompt engineering on the user's part. So there is a pretty significant gap in terms of how we expect AI to become more capable versus how we would like a junior developer to demonstrate more and more capable skill set. So I want to quickly recap what we learned from these two studies. The main takeaway for us is that the taxonomy we initially developed through analyzing the agent rules are pretty well aligned with the key values senior software developers trying to follow and teach their junior peers in the industry. And we need to start considering, some of the behavioral expectations in this taxonomy and operationalize them for the future, to guide the future development of AI and make them more useful tools for software engineers. One of the methodological insight we want to share is that we can learn quite a lot about expected system behavior from how people have been customizing their own systems. And I think this approach can generalize to other domains and organizational contexts. This also speaks to the importance of giving the user some ability to tinker with their system. This is not only a way for your system to be more flexible, but also provide a mechanism to generate really rich feedback data in the forms of configurations and settings. So that's the first thing I want to highlight, right? Learning user preferences from customization might be a pretty generalizable approach towards AI engineering in the future. And then we need to start considering how we can create new generations of benchmarks and evaluations. focused on the multidimensional nature of code quality. As we have demonstrated, the narrow focus of Sui bench on functional correctness is not enough. It does not speak to all the quality criteria practicing software engineers actually care about. So when you start thinking about how to expand the definition of success, last but not the least, collaboration is getting more and more important, because for any non-trivial problems, it is very likely it cannot be solved in one shot. The developer needs to converse with AI, trying to get to the common ground, and then supervise AI over multiple turns. How to make sure that teamwork is actually working as intended is important. So we have been exploring how to tackle these challenges within Google. I don't have publicly available materials I can share at this time, but I would like to offer two examples I have seen from the industry and academia as kind of proxies to demonstrate how the field has moving in those directions. So one example I want to highlight is a relatively new benchmark called Frontier Code, developed by a startup called Cognition, and they are introducing this new idea of code mergeability from the eyes of open source code maintainers. The main question they're asking is, would the code maintainer actually merge this pull request? And pull request is a term for a piece of for a contribution by a developer intended for a open source project. So when someone submits a pull request, the code maintainer will need to review the quality of this pull request, and if it meets their standard, it will be merged into the mainline code base. And in Frontier Code, mergeability is broken down in 6 axes. Right? The first one is very familiar, behavioral correctness. It is what Sui bench measures. It is still important to make sure the program behavior is working as intended. And then the next few axes are other aspects of program correctness. Right? It relates to whether the task introduced by this pull request is actually testing the right thing, or the scope of the work is strictly limited to the original issue description instead of doing something on the side, which again is actually relevant to one of the behaviors in our taxonomy. But what I highlighted here is the last one about code quality, and it speaks to the requirements related to following conventions and the readability guidelines, and it needs to be evaluated differently than the rest of these axes, which all can be more or less determined through a deterministic tool, right? You run a test or you run a script to find out if this code is doing that thing as it's as intended. But the code quality question is often subjective, right? The style guide will often describe examples, and they are not exactly matched to the code being evaluated. So one of the approaches AI researchers have been taking to tackle that challenge is to use another LLM as a judge. And the way it works is to give a carefully defined rubric to a LLM, and then ask the LLM to act as a code reviewer and check the code being evaluated against that rubric. There is a lot of details to get right, and sometimes it requires an elaborate collaboration process to make sure the LLM as judge is actually acting similarly to a human reviewer. So it's often easy to start, but harder to get right. But regardless, this is a interesting development in the industry, closely aligned with the ideas we proposed from our research. Another example I want to share is a paper from a few different universities. I think MIT, CMU, Stanford, and the University of Washington were all involved in this paper. titled "Completion Does Not Equal to Collaboration: Scaling Collaborative Effort with Agents." So this paper is not specifically in the software engineering domain, but it starts to address two still very open questions we need to address in order to measure collaboration quality between AI and agents. The first question is, how do we operationalize user effort? And in this paper, they took a few like proxy metrics, such as the number of human latents in a multi-turn conversation, and then how many tokens were included in those human turns. Very simple and straightforward. And you can imagine there are much more sophisticated ways to operationalize the user effort construct. And then another open question the researchers are trying to address was how we could simulate a multi-turn conversation so we can repeatedly measure the effectiveness of AI agent against the same initial prompt. So the authors of this paper build a user simulator based on a LLM, essentially asking the LLM to role play a user. And the prompt for that user simulator LLM includes three parts. First is the definition of the persona, like what kind of user it is and what are their goals. And then the user simulating LLM will then will be given some hidden information, which was not disclosed in the initial prompt, but then the user simulator can choose to share them if the main agent run into trouble figuring out the details of the task. And then the third piece of the prompt for the user simulator is a set of conversation guidelines to make them feel more natural and better aligned with how a user would talk. So this, I think, is becoming a more and more common practice, but there are some recent papers showing the differences between how LLMs talk like a user versus how real people talk in a conversation with the AI. And there are more sophisticated techniques which could involve like fine-tuning a large language model with a corpus of user messages. And this is a very active area of development. And if you are interested in this, definitely watch this space closely, as there are many research studies being done to make sure that we can actually rely on AI to mimic a multi-turn conversation with a user. This brings to the end of my talk, and I would like to thank you all for coming. Hopefully, this is interesting and useful to you. And for me, I feel as a HCI researcher and practitioner, we always have a kind of unique capability to help the field understand, what kind of goal it was pursuing. As you can see from those benchmark charts, it's always up and right, but sometimes what's asking are we climbing the right hill, right? So this work is trying to reframe the conversation a little bit and get everyone take a step back and think about what besides functional correctness is also important, to software engineers. And I want to acknowledge the contributions of my teammates and thank all the participants in our study and my colleagues for their support. There is a full paper about this study, so you can either follow the link up there or scan the QR code to get to the PDF. I also irregularly write a newsletter on Substack about AI evaluations, and I try to take a HCI perspective in reviewing popular benchmarks or evaluation suite different companies or labs put together. So if you are interested on that topic, I'd appreciate you check out my Substack. So you still have some time for Q&A, right?
Of course we do.
Okay, yeah. And I have my contact information up there. So in case you want to connect with me offline, feel free to reach out.
Well, very provocative, an awful lot of information very quickly. And I've got, my God, I've got 10 questions for you. And I don't think if I dominate this, that won't be good. But I want to just start by asking, Ted Selfer asking a couple of things. I'm watching at the beginning of this talk a lot of directives when you're talking to the AI.
Yeah.
And, I just, in terms of the language, you brought it up many times, the language between them, and is critical or is helpful to people. But a lot of AI, I've worked with this too, problems are, it sounds pandering. That means it's talking down to you, and then you're talking like an authoritative, got to do it my way. And I think that there's that mismatch of styles seems to be difficult to overcome. Do you want to just say a little bit about, because you brought up language several times, but I really feel like what the people are there, because people are they're so hopeful that they better tell exactly precisely what they need, which is great, but they use these words that you'd never use with a person. And so any comments on that?
Yeah, just make sure I understand your question correctly. So you are responding to the wording in the rules.
The wording is from, of course, the person, which ends up being very directive, and the wording is from it, which ends up being pandering. And so the mismatch of this submissive and this heavy-handed thing, it's almost, there's no collaboration. That's a slave and a boss, and I'm not sure it actually builds the kinds of cooperative experience that one hopes to get with somebody they're bouncing things back and forth, of which you over and over again said was your goal.
Yeah, I think it's a really interesting observation, and I feel we are in this kind of transitional period where like some developers see AI as purely a tool, but some developers seems to start to think AI can do work autonomously and started to consider it more of a partner, at least a virtual partner. And there is a lot of folk knowledge involved in how to prompt AI effectively. And I can see some of the rules might have evolved over time, incorporating such like folk wisdom. You can see some rules have like all caps, right, to emphasize certain words. I remember at a certain period of time, there was this kind of suggestion that you really need to emphasize in all caps in order to induce better like instruction following in AI models.
Maybe you need a whip. Yeah.
So I think the practice is definitely still evolving. And one thing that is an open question is how can we give users tools to figure out the best way to talk to their AI? And a lot of the underground practice is very much trial and error. Like they try something, they observe if any change has happened in the direction they were hoping for, and then kind of move on. But in the case of software engineering, many developers are actually interested in a more rigorous way of testing their instructions for AI agents, not only instruction in a specific session, but also those like standing instructions in those agent rule files. And these files are also affecting like everyone who's trying to contribute to a code base. We actually had a related Kai workshop paper describing that problem more thoroughly. There is like a very little systematic approach towards governing those like standing instructions and customizations developers have put in place in order to kind of induce better behavior of their AI agents.
So on that topic, I want to talk about onboarding. And I know that I've been around a lot of people who went to Google. My gosh, it's gotten to the point where some people, they are onboarded for 3 months before they can actually touch the code base, right? So the onboarding for this kind of collaboration and working with this thing, I could imagine it being, what do you think? Is it more extensive? Is it less extensive? Is it easier to get up to speed with agentic programming than the old school getting on board to do to know everything you need to know about the security framework, and you're going to be being a security guy or whatever? How do you feel like, do you have new skills you're developing about how to onboard people around these new agentic programming? Just, I don't know what the comments you have on this.
Yeah, I think there are maybe two questions about onboarding, right? One is how do we onboard junior developers to a team, maybe with AI support? And then another question, maybe not the one you're asking, is how can we onboard, quote unquote, AI agents to a team, which is addressed by many of the rules developers have written and covered in our study. So to your question, which is about human onboarding, I think the long-term effect is still to be known. On the one hand, we have many new employees reporting a easier time because they can ask questions anytime. They don't need to get a hold of their tech lead or senior developer or mentor in order to unblock the question. They can ask AI agents. That those agents are getting more capable of sifting through a large amount of information and get them moving quickly. But there might be also the effect of losing opportunity to develop relationship with your teammates. So this is not fully studied yet. And I think in the short term, this AI agent serving as onboarding support is providing a lot of value. But what is missing is kind of the open question.
Yeah. So that leads me to another question I have up here, which is you talked about local conventions, and how there's an opacity when you're talking to an AI that, and then there's also a question of how do these conventions get embodied or trained into these agents? And how do you make it so people can recognize what these local conventions are and formalize these local conventions that are pretty much tacit knowledge often, but also change them and actually recognize what they are?
Yeah, that's a good question. It's kind of hard because those large language models are trained on the internet, right? They ingest a lot of information and data. So it's hard to make sure that they would by default follow your team or your company's standards. So what I think what the developers in our study were trying to do is to steer them away from what they would act by default, right? Going back to maybe the average style of code in their training data. They want them to explore the local code base and pick up some cues from how the code has been written by the humans on the project and mimic their style. And I think a stronger model is usually more capable of doing that, overcoming its internal knowledge and try to really learn from what's present in their context.
I'm going to just ask one more. I've got many more, but I'm not going to ask them all. So when we're getting that model inside, I imagine we got an MCP, we got some embeddings about Google code quality, and it's probably not shared with the rest of the world. How do I know? But what I wonder is, I could imagine that being at Google, where Gemini is created, that part of what you might be doing is going to the Gemini folks and helping them code in these local conventions and styles, or at least knowing what they are. Are they completely separate? Do the people that know so much about how does the Google way of programming, do they get to inform the big models? Or is it just an after the fact, embeddings and trying to filter and make it not go in some weird direction? And would there be value to guiding the real LLM development?
Yeah, certainly. And I think part of that is to create a better benchmarks, reflect sort of your team and your company standards, and then measure progress of model on that benchmark. And then use the benchmark as a tool to provide feedback to the model team so they can start considering different data they need to include in the next training run. And Gemini as a product is serving everyone on the planet. So it's not specifically tailored to any company. So it's up to us, up to customers to figure out how they want to add a layer on top of the base model to make it really work for them. And we are sort of doing similar things internally, almost act as an internal customer of Gemini to make the model, the vanilla model work better for our own engineers.
That's great. And then there's probably cross-fertilization a little bit, or pretty much not, between the Gemini team and the users.
Yeah, I think there are multiple channels of feedback. Yeah, but as I mentioned, the industry is guided by benchmarks. So it's really important to get like our ideas into the benchmark design, and then the machine learning researchers will have the right goalpost to optimize their models against.
And as I open this up to everybody else, kind of the really fascinating thing that I'm listening to is this is really the beginning and the first time in history where we are building tools that are social animals, social actors that we are creating and trying to understand and trying to figure out how to work with. And all of these questions about what that social relationship is going to be half of the fun of understanding how to make this thing not dreary or oppressive or out of control. Please, who's got some questions? Over here, please give your name, Ben.
Hi, I'm Megan. I'm kind of on the forward deployed engineering side with a background in HCI as well. And I'm curious, like, these are amazing rules and you have an amazing data set to extract them from. I'm curious, like, where do these get implemented? Are these in the memory? Are these somehow translated into hooks inside of like the settings.json? Because what I find is that Claude, when things are in memory, it tends to ignore them sometimes. And like, just like humans, takes a lot of shortcuts and even recently has disobeyed things that are in settings.json. They like found workaround for them just straight up did the thing it wasn't supposed to do. So you guys have you guys implemented these guidance systems and what are your, if you haven't done, have you found ways to make Claude like 100% reliable, which I don't know that exists, but
yeah, it's hard to make things
right, yeah,
it's not a deterministic system, and we the rules we analyzed originally part of the agents.md file, so they get ingested by the agent automatically into every session. It's almost become a part of the user's prompt. But then there is still this open question about which styles of rules would actually work at it. And there isn't a really good way to test that systematically. And many users don't have the appetite experiments on different versions of rules. So there might be a good opportunity for HCI practitioners to consider what kind of easy to use prompt testing tools would be valuable to users who care about results but don't want to spend too much time A/B tests in different ways of writing their instructions. And we have also been trying to incorporate the taxonomy we developed into our evaluation systems. As I mentioned, we are exploring on similar lines as some other companies are doing with the notion of code mergeability. How can we define the criteria from the perspective of the people who maintain the code, right? If someone who's submitting code to their code base, what are the important standards that code needs to satisfy in order to be eligible to be merged?
yeah, like you could tie it to certain like GitHub actions or states, right? Like pushing something and then making it ready for review, maybe like triggers all of these and run goes against all of them. But yeah, I was just curious if you guys had figured out reliable ways to do that. But
it's always an ongoing process.
Yeah.
Other questions?
I have one question. I would love to hear your thoughts on, my name is Volkan. On the collaboration, I noticed that you highlighted the collaboration between humans and AI. Like we are slowly testing agent-to-agent collaboration. I'm curious if you have any thoughts or not.
So this study does not really speak to that question, but it's definitely being practiced more, right? Having an agent to coordinate a bunch of like sub-agents. I don't have results that can directly speak to that problem. So that's something like we are still like looking into at the moment.
But a place in there that's interesting is when you have a flock of agents, I don't know what's whatever, but and a person's interacting with it. Do they interact with it as one agent, or do they have to work on look at all of them separately?
I think it adds a layer of abstraction. Right? Usually, the user interacts with the main agent, and the main agent will relay the messages between the user and then the sub agent. And sometimes the main agent also like rephrase the user's request as prompts for the sub agents. That rephrase message might or might not capture 100% of the user's intent. So how to keep the user in the loop and maybe audit what the main agent has done to delegate smaller pieces of work to sub-agents is an interesting question like we should explore like further. And I feel maybe the current coding tools have not been designed well enough for the user to kind of manage a fleet of agents well. It's sort of like hiring a general contractor and then you kind of lose sight on what the work is actually done, how the work is actually done.
That's pretty.
Yeah, I was also interested more between not the sub agents, but imagine there's the one problem domain, you have a group of agents, let's say you are doing, and then maybe a separate problem domain where you are going to almost like a contract out to the other agents. So I was really thinking beyond the sub agent use case. Like human is still in the picture, but the problem imagine is so large. You are basically utilizing multiple groups of agents, kind of like divide and conquer. So human is still in the picture, but collaborating, I guess, amongst those agents, like.
I guess what he was saying is that he didn't get.
I understand.
There were a few other questions, and please you can get back to it too. But we haven't heard from you, so.
Hi, I'm Nina, and one thing I've heard from both developers as well as knowledge workers is that, I delegate this task to AI, but any kind of time or productivity gains I get from it kind of just get spent up on reviewing what the AI has done, reviewing the code, because I don't want to pass off work that has my name on it, but I need to kind of review the AI's output, and that's really affecting how AI gets used for productivity. I know like the kind of taxonomy speaks to collaboration requirements, but I was curious if there was related feedback in the interviews at least about how developers would maybe review the AI outputs, and maybe this gets into some of the mergeability, code mergeability aspects as well.
I think this is related to a few of the agent rule categories, the behavior rules. So it starts with self-verification, right? Agents should first run tools to validate their own work. Usually, in a mature code base, you have many automated tests already. They should be performed before the agent conclude the work is done. And then a few other rules are put in place to make it easier for the developer to verify the AI's work. For example, like work incrementally and iteratively. It is much harder for the developer to validate a huge chunk of code than like smaller pieces targeting specific problems. So that category of rules are serving like two goals. One is to make sure the errors won't compound over time, right? If the agent is solving a long task, the errors in every step is going to compound. And the other purpose is to make sure developers can like check in different places of this journey.
So this actually reminds me of, we had a guy named Jude Yu. Do you know him?
Yes, I know Jude. Also from Michigan, Jude.
Yeah. Oh, okay, Michigan. Okay, it's cold there. It's hot now, but maybe there's flies. But in any case, he kind of said that the validation, his expert programmers were finding the validation phase of making code with AI was so much greater than the validation of code that they write with their VI editor or whatever. Is that just those experts that he's been dealing with, or is that over? Or I mean, I love the point that you have. There's this code, all these tests that are already there, and most have used them. Just say a little bit about is validation, still harder with AI, or is it going away now?
It is. I think it is still a problem. It's probably a growing problem.
Yeah,
I'm not speaking specifically about what we observed within Google, and I think it's kind of recognized as a growing problem for the industry. And overall, the kind of the developer's job has starting to shift more towards reviewing code than writing code in the first place. But also there is a lot more work on writing the specification of software, which then is the input for serve as input for the AI agents. I guess the abstraction level of the work has been raised to towards a better definition of the problem itself, and breaking down the problem to make each unit like workable by AI agents, and then towards the end of this progress to check the deliverable is good.
Right. So there's two things that I don't want to take over. I want to make sure I get to the next question, but two parts of this. First of all, it was always important to specify, and a lot of times these project managers or product managers aren't really the right person to specify. So now we have coders doing, maybe we can get better specifications that are critical. But the second thing, and you can comment as you should, is that historically the maintenance of software is 90% of the cost of software. And do you think that any of that equation changes or is exacerbated by AI agents?
I think it highly depends on the nature of your project, right? So speaking to the data we have in this research, we are looking at a very mature code base. And that's why you find all those rules about code quality following standards, because the new code is getting integrated into a existing code base that is serving lots of users, right? It is very different from like a startup trying to create new apps. They probably will focus on validating their ideas as quickly as possible, because it's expected that you might need to rewrite your systems many times in search of the product market fit. But for a mature company like Google, and I think that applies to other large tech companies as well, the stability of the code base is more important than getting code through the system as quickly as possible.
I think there was another question you were going to ask.
Okay, so I think I have a question that I think partly overlaps with one of the questions from before. So when you were showing the taxonomy and the example directives for each, right? I kept thinking that most like all of these seem to be directives that would be universally good, regardless of what the team does, right? And to the extent that they were customized, they were referring to constraints that were outside of the directives. For example, go learn about the local norms, right, of the code base. And so then I was thinking, why wouldn't the company want to then, capture all of these and then incorporate it, just once and for all into like the that is used for coding, rather than just leaving it to the discretion of each team? Because they're just going to come up with the same thing again and again, right? If they're like universally good. But then at the same time, you were also referring to them as values. Now, the thing about values is that there is something tricky about values, which is that they are sometimes at tension with each other. Right? That you have to sacrifice something to gain something else, right? So do you actually think of these as values? That is, it's actually the prioritization of these that would be customized to each team? Or is it more like, directives that are universally good? Does that make sense?
It makes sense. It makes sense. I think it's a deep question that I need to think a little bit more about. Maybe to the first part of your question, some rules does feel like universally applicable, at least within the Google environment. And I think over time, model teams are incorporating some of the behaviors into their training through influence over the how the system is evaluated and how the data is collected. And another open question is, it's unclear when it becomes unnecessary to have those rules, right, explicitly specified. It's very likely that developers put in a rule because they run into an issue with agent and they want to avoid the same issue from happening again. but those rules tend to be additive. Like you don't evaluate critically, periodically to remove rules once you have a better model, right? So that speaks to the difficulty of making sure that each rule is playing a unique part. And in terms of whether we should consider them as values or universal sort of principles to follow, and I think it would be useful to consider a longitudinal study, which we have not done yet, to monitor whether these rules are getting modified and whether different teams have conflicting rules. But in general, since we source those rules from a single company, some sort of convergence is expected. There are local differences in terms of different coding styles that might exist in different projects, but at a high level, these engineers are still trained within the same company. So it's sort of expected that they show sort of similar values in those rule files.
So we have a few questions online. Kevin, do you want to turn on your microphone and say what you were asking here? Kevin Boyd?
Sure. So I've been reading quite a bit lately about the amount of machine code versus human code, and essentially the code reading burden, and the issue of so if coders are being supplemented or replaced by, to some extent, by AI, there tends to need to be a human in the loop, so there's someone to blame if something goes wrong. Does the researcher talking about support a future in which humans need AI to review code which was written by AI and humans?
My research doesn't directly address that question, but I think in the industry there has been AI tools created to support code review activities, and I think there are certainly utility, right, in these tools, because code reviewers needs to do a lot of basic investigation type of work, and having AI tool can potentially help them, find the information they need more quickly.
Pierre Chao Mi, I don't know how to pronounce your name, says you can ask your question, or I can.
I think they don't have a mic.
Maybe they don't. I'm new to software development. Can I add these add skills to my project based on these guidelines?
Yeah, I think probably not exact those guidelines, since they are specifically derived from the instructions developed give to AI in a mature software company. If you are working on a very different style of project, you might need to consider adding guidelines personalized to your needs, right? So we need to consider what are the common sort of failure modes you have encountered with your agent, and then create rules in order to prevent those errors from happening as frequent as they were. So that would be my suggestion, and these are not rules that would be kind of universal outside of the enterprise software engineering context.
Interesting question. Answer. There's a lot of I was going to say, in the back row I see a lot of people nodding, and it's obvious that people have experience with a lot of the same problems you're talking about. So I'd love some more questions. Please, your name?
Quick question. My name is Bill. By the way, I've been at Big High 35 years.
Thank you.
I go about from another domain, construction, since you mentioned subcontractors. So some cities have found that rather than having binders and binders of rules, which was really inefficient and frustrating, they shifted to being goal-based. So you use the word rules or values, but is perhaps goals can be more effective, not now in the future. And in construction you have building codes, but those don't really specify the values. But it seems like goals would be maybe where this is headed. So now it's harder to violate a goal. Of course, the main goal is to be a profitable company or serve humanity, but the real thing sounds like that's just way too low level. So maybe the goals would give more flexibility to have a better outcome.
Yeah, I think that's a very good suggestion. I think that's,
Would you say some of these rules are kind of goals already?
some of those are goals, are framed as goals, right? They
Rules tend to be like don'ts. Don't.
That's right. So you have we have observed a mix of styles of those rules. Some of those are more about, what the code should look like, whether they conform to this style guide or not, right? And some others are much more detailed. Don't do this or don't do that, and they are likely from different, originated from different situations. And I can almost picture the onboarding process where the developer would convert their existing documentation for new joiners to AI agents to give the agent context in order to work effectively in the code base. But then they will incrementally add new things to that agents.md rule file as they encounter undesirable behavior of the agent. That's where you are stuck to see those very specific, don't do that or don't do that, don't do this type of content.
Thank you. Very interesting. Any other questions? Yes, please.
So quick question, for lesson learned in the last point, and you have like a lesson learned.md. Is that intent for human beings to read it, or say next iteration you will send over to agents that improve the next round of work?
So that was intended for the agent to consume in future sessions. It is, I think, a sort of a home-baked memory system for agents. Again, we collected the data last year, so there are actually much more mature memory systems in all the major agents today. But that was sort of a stopgap solution some users come up with when there wasn't a systematic mechanism to keep memory across agents.
So another follow-up question. So make a mistake over, right? So people say, best people don't make same mistake again, right? So over time, you say do the project, agent modify that, lesson learned. Over time, did you see lesson learned just stabilize out there, don't change anymore?
We haven't done that analysis yet. It's still I think emerging practice to keep a long-term memory for agents. It will be interesting to see whether those memory files stabilize. I suspect there is still this question of whether there is sufficient signal for the user to remove things from that memory file, right? It's likely to be additive over time. You just add one more thing as you encounter to a new problem. But there is still a cost of having that memory grow in size over time because it takes up the context window of the agent.
Okay, cool.
Sure you can, but you have to say your name.
Oh, my name is Steve. Software development background, so I interested in the API work as well. So related question is we talk a lot about the code generation, mainly for coders, right? So in the code generation, we also have to run a unit test, right? This is good, but sometimes it's not good as well because why US government have 3 branches, check and balance, right? So we still need to have some extra testing after you ship the code, right? Smoke testing or function testing, all those things. So is there any work related over there, say make more AI agent more productive, more overall automate all the software development process?
Yeah, I think there are AI agents in different parts of the development cycle, right? So what I talked about today is mostly about this so-called inner loop of development, right? You edit some code, you then run the code and see if it's working, and then repeat. Then there's this notion of the outer loop of software development, which is about deployment, getting feedback from production, iterate the build over time. There are products, not just from Google, but many other companies to provide support in those outer loop activities as well, like monitoring production issues and try to help developers like debug what is causing a crash, for example.
Okay.
Yeah.
Hopefully someday like those agents can monitor issue, find a bug Jira, and then Jira just trigger your code to generate and then send over to GitHub, right?
Yeah.
But again, we still need a human in the middle.
Well, even if it isn't a
brain.
you need consideration, reflection, and assessment in the middle, right? And that if you don't, and I think, and I've seen even my students often will go use a different LLM to test their code and find amazing things about how to improve performance, find bugs, even from a different company's LLM.
Yeah.
Some more questions?
I have a question. My name's Jesse.
Hey, Jesse.
You mentioned a lot about benchmarking.
Yeah.
Do the models just go and train upon these benchmarks in order to kind of, prove their, exactly.
Well, that is a bad practice, right? Usually model teams avoid training their model on benchmarks. Then if they do that, then the benchmarks don't provide signals for them, right? So it is sometimes difficult to avoid because many of the benchmarks are based on publicly available data, like the SweBench example we talk about. The examples come from GitHub. So it's possible that a model has already ingested the data from the same GitHub issues and even the solutions. But usually, like model teams don't specifically train their model on those benchmarks. It's kind of a form of cheating.
Thank you for this talk. My name is Edwin, and I've been finding this fascinating. One of the things that, this is very personal to me. So I've been working with an LLM as a brainstorming partner to work through a lot of different problems as I try to triangulate and develop what could be a product, very small product or whatever. At least 30% of my time I've been spending on improving our interaction as collaboration. And that has taken the form of all kinds of stuff. Like I fed it essentially, personality assessments of this is how I interact with things. I've developed a practice of, after a long discussion, working through a problem, of reflecting on that to see how to, how did the ideas come out? How do we encourage that? How do we structure and shape our turn takings to improve that interaction? And I've developed this whole separate almost system of tracking. This is how to interact with Edwin.
The question,
and it has been, and so the collaboration layer that you're talking about, that feels almost like that is almost entirely what I've been working on. What have you found? You said you haven't yet analyzed the lessons learned file, but
it is pretty aspirational, I would say. It's unclear whether it is actually working as intended, but we take that aspiration as a requirement for the systems to improve on.
And so I'll share that what I have found just phenomenologically, that my interaction with this thing has been much smoother, felt like less work, and produced more interesting insights. But that is that has come from a lot of hey, we're going to dedicate time to improve this layer of work. In the spirit of customizing for teams, customizing specifically for an individual, I don't know how much that scales, but data point of one, I'll share that it seems to be working.
I feel you are speaking to the same process many professional developers take, right? You need to have some sort of onboarding process for your AI and to make sure that you understand how the AI agent typically respond to your requests and what it needs from you to be effective. And then I think what you did was a lot of context engineering, right, to make sure that the AI has the right information to give you something you ask it to do. And at the same time, you are assessing its capabilities. So you don't either overestimate AI or underestimate what AI can do. It feels like the outcome is that you are calibrated to give the AI the kind of work it can do well based on the information you provide. So it feels like a very common process. Like AI is not something you can get like full value out of right out of box. That you kind of needs to like play with it a little while, put in some effort to really know this tool, right?
It's also very it's also provided me an opportunity to understand better myself, like what it is I need, how I'm working, when do my insights come in. And that has been just a surprise. I was not looking for that, but.
Okay, we've been at this a while. I don't want to wear everybody out, but let's maybe one or two more questions. Has anybody else got something they want? Oh, wait, your name?
It's Satvik. So you talked about the evaluation, right? So at the end, you said these are the values, these are the evaluations. So I saw P1 and P6. What does those mean? Like, are those the priority? And so if you have multiple models in comparison, then would they have the same prioritization in terms of the benchmarking that you would put in?
Good question. So I forgot to clarify what those mean. Those are participant numbers.
Oh, okay.
So P stands for participants. These are not priorities. And we have not really stacked rank the values or the like, behavioral expectations in our taxonomy. And again, will be interesting to understand whether there are any tensions, between different expectations and values. One thing I can actually think of is like how much is related to how much you want AI to proactively validate their solution, because there is a cost of running all the tests, right? If you want the AI to always run the whole test suite after building something, then it will produce more latency in its response. So there is a bit of I think tension between quality and speed of delivery. And if you are working on a prototype, you might want to loosen that requirement a little bit, right? Because you can potentially see the outcome just from the live application, and you will consider that quality question a little bit later in the process.
I want to follow up with this thing.
Yeah.
So in traditional AI, there were things like blackboards where there's conflict resolution when you have multiple agents simultaneously saying, I can help in this way, I can help in that way. And have you thought a little bit about this back to prioritization? Do you have how do you regulate? You've got, you say we're aggregating more and more rules. Is there any turnstile or some way that you are evaluating which rules to take charge at one time?
Yeah, I think one more recent development is the rise of a new tool in AI agents called Skill. Some of you probably have heard of that. So Skill is a way to kind of decentralize the rules you put in the agents.md file into different pieces that you can load on demand. You can have a skill for testing, for example. You can have a skill for reviewing code. You essentially can ask your AI agent to put on different
So it's prioritized by the software developer.
By the software developer, right? So it's not all together, but more like scenario based, and it can also invoke access to different like knowledge bases that might be relevant to that scenario.
I don't know if this run its course or if somebody with a dying question that hasn't got a chance to ask it. Is there anybody else that wanted to ask a question, or should we just walk out into this warm evening together, or share a few more discussions with each other before we go home? Yes, yeah, please, one more.
About just running this type of like AI evaluation research. I see like this might be a good framework, like developing some rules and looking at how people have been given the instructions. Are there any other of research activities or type of studies you would recommend if we want to do this type of AI evaluation research?
Yeah, and I think this touches on like how sort of HCI folks can contribute to AI evaluation, right? It is maybe useful to look at the components of a AI evaluation suite or a benchmark. So one thing is the examples in the data set, right? What kind of tasks are included in the benchmark data set? So this is the first place I think HCI perspective can influence that. We need to make sure that the tasks included in the benchmark are representative of the actual tasks users care about or the product is trying to support, right? Sometimes you might see tasks selected just based on the ease of measurement. They are like more manually defined or they are more complete to measure. So we need to point out the trade-offs. And then the second question is about how we design the verifier, which is a term used by the machine learning folks. So once we give the model the input or a prompt, then how do we verify the model has done the work correctly? So the verifier can be deterministic, right? It can, for example, sometimes you just want to check the calculation result and it's deterministic, but oftentimes it's open-ended. Then the question is, how do we design a rubric that is aligned with what counts as good outcome for the user? So I think a lot of user research techniques can be useful to inform the development of that rubric. And then a related question is, how do we make sure the rubrics can be accurately used in the assessment? Because many of the benchmarks use LLM as a judge, then there is a bit of human factors work needs to be done to make sure the LLM judge aligned with human expert judges. So I would start with these three places, and I think maybe the main tension we need to manage is that AI model teams really want those benchmarks to be scalable, repeatable, and very efficient because they want to iterate quickly. Sometimes that goal is at odds with a common HCI goals of trying to be representative, trying to capture the messiness of the world, right? It's at odds of the sort of the cutting room norm of the model teams.
So I want to just say to the greater audience that we have various kinds of talks here. Sometimes it's a scenario of somebody's giving the UX for a driving car or some other or something like that. This is we're really down today in bowels in a way we often aren't, but it's a very appropriate and timely direction that everybody's concerned about. And I think that it's the questions that people have are very important questions. It's obvious to me this kind of ethnographic studying that you're doing, which is this mixed methods, the thing that you're doing is really pertinent. And I can see that there's just a very rich area, and I'm expecting to hear more exciting papers from you and very important work that's going to come up. And as this thing matures, it's going to be fascinating, probably for you, to watch how this evolves and how we as HCI researchers can help guide it to be a world that's kind of fun. I mean, I like programming, fun to build things, fun to test them, fun to deploy them, and it isn't just a whips and slaves situation. So with that, I don't know if that's helpful, but with that, I think let's devolve and turn off this recording, and people can stay for a few minutes, eat up some cookies if they need to, and meet each other a little bit more. And thank you everybody for coming. And especially we have another 15 people that were online. So this was 75 people that you had in 50 people you had in this today. 35. 40, excuse me, 40 people. I can't count. I have a degree in applied math, guys. But anyway, I can't count. So thank you very much for everybody for attending. I hope everybody got something out of it. And we'll see you next month.
Thank you.